Okay, this is the Chapter 2 test, just a review of how to work the problems. I gave you number 1 is f of x equals square root of x. I want the equation of the tangent line when x equals 1. If you put 1 in, you get 1 out for the y value. Then I will take the derivative, power base, 1 less power, derivative of base. The base is what is raised to the power, so the base is simply x, and this would be my derivative. If I put a 1 into this, I get a slope of 1/2. So I put a 1 in, and that makes my slope 1/2. Y minus the y value is equal to m times x minus the x value. So y minus, and we're going to fill into the point slope form. The y value is 1, the x value is 1, the slope is 1/2. Y minus 1 equals 1/2 x minus 1/2. Add 1, and you get y equals 1/2 x plus 1/2. That would be the equation of the tangent line for number 1. Now, number 2. Same instructions, but I gave you a fraction. 6 over x plus 2. And I said when x was 0. Putting a 0 in gives you 6 over 2, or 3. So I now know my point xy. Now, if I take the derivative, I personally would not use a quotient rule because the top is a constant. If the top or bottom is a constant, I tend to rewrite them and avoid using the quotient rule because of the constant. So I keep the 6 out front. Power, base, 1 less power, derivative of base. So I get negative 6 over x plus 1 quantity squared. If you were to put in a 0, is that correct? If I put in a 0, what does this give me? I believe that gives me a negative 6. Does that sound right? Let me take a look here one moment. Thank you. I don't know why, but I made that right there. It should be x plus 2, should it not? I think this should be right here, x plus 2 to the negative 2. So that makes it into this for the derivative. And if I put in a 0, what do I get for my slope? Negative 6 over 4, which simplifies to make the slope negative 3 over 2. So now that I know the point and the slope, I should be able to write the equation of a line. Point slope, y minus the y value is equal to m times x minus the x value. Filling it in, what is the x value? 0. Y value, 3. Slope is negative 3/2. If I multiply this, I get negative 3/2 x. And if I add the 3, I think I would get this. So these are the equations of the tangent line to the curve at the indicated point. Now, if you had a graphing calculator, it would do all this work for you and give you the equation, assuming you know how to use your graphing calculator. Most of them, you would do second draw tangent and give it the x value. That's most of the TI calculators. Okay, we did 1 and 2. Let's take a look at 3. I'm going to find dy dx. So I take the derivative on the left would be dy dx. Derivative of 4x is 4. Power base, 1 less power, derivative of base. The base is just x because that's the only thing raised to a power, and its derivative is 1. So you get your derivative to equal this. Now, I didn't ask for this in an equation form, but so you could have given me this as an expression. Now, the derivative here, dy dx, you have to realize that the third root means a 1/3 power. Power base, 1 less power, derivative of base. So because the problem is in terms of a radical, I probably should express this in terms of a radical. I'm going to move it to the bottom, but it's going to be power over root. So that means it's the third root of x squared. So that's kind of what I was looking for in number 4. Number 5, the derivative of 3x would be 3. Now this could also be written as 2x to what power? So I could rewrite this. 3x minus 2x to the negative 2. So what is its derivative? The derivative of 3x again is 3. Power, base, 1 less power, derivative of base. So I think that becomes plus 4 over x cubed. So these should be the answers for 3, 4, and 5. Okay, after 5 we're going to try 6. It's a quotient, so I'm going to do the quotient rule. So the quotient rule says the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So that makes this into x cosine x minus sine x, the whole thing over x squared. It's just a quotient rule. Now, number 7, I see a product, two things multiplied together. So again, I'm going to use the product rule. So I'll bring the x squared down. The derivative of cosine is negative sine of the same angle times the derivative of the angle, which is 3. Plus the other way around, bring the cosine of 3x down times the derivative of x squared, which is 2x. So I have negative 3 x squared sine of 3x plus 2x cosine of 3x. And that would be my dy dx. Okay, number 8, I have another product here and an addition. So I'll do the product rule. I'll bring the x down times the derivative of sine is cosine of the same angle times the derivative of the angle. Plus, bring down the sine of x. The sine of x times the derivative of the, bring down the sine of x times the derivative of the x, which is 1. And now what's the derivative of cosine? Negative sine, same angle, times derivative angle, which is 1. So this gives me x cosine x plus sine x minus sine x. I think when you add something and its opposite, they cancel or add to 0. So my answer was x cosine x. So that would have been my derivative. Yes, when I did a product rule here in 8, let me change the color. I did u is x, v is sine. So this is u is x, this is v prime, the derivative of sine is cosine, plus the sine, which is v, times u prime, the derivative of x is 1. So yes, I did a product rule on 8 and 7. Okay, I'm going to move on to number 9. This is another product, so I need a product rule. I will find the derivative using the product rule. Bring the 3x squared down times the derivative of this, which is power, base, 1 less power, derivative of base. Then I would put plus. I'd bring down the 2x minus 3 to the 4th times the derivative of 3x squared, which is 6x. Now, 2 times 4 is 8 times 3 should be 24x squared times 2x minus 3 to the 3rd plus 6x times 2x minus 3 quantity to the 4th. Between 24 and 6, you can factor out a 6. X squared and x to the 1st, the smaller power is x to the 1st. 2x minus 3 to the third or the fourth. The smaller is 3. So I have to figure out this times what gives me this. Well, I already have the quantity to the third, so really all I need is 6x times what is 24x squared, which would be 4x. Now on this one over here, you already have the 6x, you just need that to the fourth. You have it to the third, so you might need it to the first. So you get 6x times 2x minus 3 to the third times 4x plus 2x is 6x. 6x minus 3, you can factor a 3 out. 3 times 6 is 18. And 2x minus 3 to the third, if I factored the 3 out, would be 2x minus 1. So that's the idea, the answer I was looking for. That's why I always put simplify as one of my top instructions on every test or quiz I ever give. While on the topic of simplifying, I would always simplify before you do anything. I see this as a 1/2 x cubed minus 3x squared, and they're divided by x. So I kind of see this particular problem as 1/2 times x squared minus 3x. So when I take the derivative of x squared is 2x, and the derivative of 3x is 3. So if I multiply this in, I get my answer for the derivative. Now, that's probably the easiest way. A lot of people did not simplify this first and made themselves a very challenging quotient rule. I don't know why. I'm trying to teach you the better approach. I can get this same answer through the quotient rule if you like, but don't you see x's on top and bottom? So why, if nothing else, at least simplify it to x squared minus 3x, the whole thing over x, and you maybe use a quotient rule, 2x. Try and use a quotient rule on that. I don't think I would do a quotient rule on an unsimplified expression. You're just making it harder for yourself. You're absolutely right. Not 2x on the bottom. If I actually divided the x and divided in, it would just be a 2 on the bottom, right? You're absolutely right. And then you could do a quotient rule, but why? It's a constant. Okay, some of these questions, like I said, I think I wrote it pretty close to advanced placement exam style, because a lot of these you can do a very long convoluted way, like this quotient rule at the bottom here if you didn't simplify it. And a lot of them you can do an easier way if you understand, such as number 11, natural log and e cancel, and this is really just y equals x squared. So its derivative is 2x, right? I mean, that's as easy as number 11 is. Okay, if you didn't see to simplify it like that, you could do the natural log of u. Derivative is 1 over u times u prime. That means u would be e to the x squared. So I do 1 over u. U prime, the derivative of e to a power, is e to the same power times the derivative of the power. So I'm going to multiply that by the derivative, which is this. So you end up with, on top, 2x e to the x squared divided by e to the x squared. Those would cancel, and you could still get the derivative that way. It just would take longer. And on a timed advanced placement exam, you probably don't want to spend that time doing unnecessary work. But if it gets you the right answer, it's worth it. Okay, for number 12, we have e to a power, so I have to take its derivative, e to the same power times the derivative of the power. Because the power is a product, I need the product rule. X times the derivative of y plus y times the derivative of x minus the derivative of y squared, power base, 1 less power, derivative base. Because it's a y, you put dy dx. The derivative of a constant is 10. I see that there's an addition here. That should clue me in that I might have to distribute. So you get x e to the xy dy dx. This would be plus y e to the xy minus 2y dy dx equals 0. Now, I see that there are two terms with dy dx and one that does not have dy dx. So I'm going to subtract the y e to the xy over, and the two underlined things, I'm going to factor dy dx out. So that would be x e to the xy minus 2y. Now, if I want dy dx, and this is multiplied, all I have to do is divide. So this right here, if I divide it by x e to the xy minus 2y, that's the answer I got. If you happen to bring the things to the other side, you might have gotten a positive y over e to the xy, and on bottom would be 2y minus x e to the xy. Either of these would be correct answers. Okay, 13, arc sine. I know that the derivative of arc sine of u would be u prime over radical 1 minus u squared. What is u in this case? X over 3 or 1/3 x. What does that make u prime? 1/3. So when I fill in, I got u prime on top. On bottom, I have radical 1 minus u squared. So I put my u prime on top, and I'm going to fill in my u, which is x over 3, and that is squared. So that becomes 1/3 over the square root of 1 minus x squared over 9. In high school, I will never accept fractions in fractions, double signs, negative exponents when they're inappropriate. There's certain things that we have to be, decimals mixed in with fractions. Show commitment. Go all decimals or all fractions. Opposite of dividing by 3 would be to multiply by 3. So I'm going to multiply by a fancy form of 1. On top, I get a 1. On bottom, they're both under square roots, so I can multiply them. 1 times 9 is 9, and these 9s cancel, leaving me this for the derivative. If I had, this is not my answer, but if I had the square root of 9x squared and they were multiplied, yes, I could probably simplify that. But because these are subtracted, it's really the difference of squares, 3 plus x and 3 minus x. So I can't really take the square root of the bottom. It doesn't simplify. That's why I have to leave my answer like this. Okay, 13, we're going to move on to 14. 14, I have a product because you have two things multiplied here. And I have a product over here, but the 2 is a constant, so I don't need a product rule on that one. But I do need a product rule on this first product. So I'll bring down the 2x times the derivative of arc cosine. If I wanted the derivative of arc cosine, it's the same as the derivative of arc sine, but it has a negative. So it's negative u prime over 1 minus u squared. So if u is x, u prime would be 1, so it would be negative 1, and it would be divided by 1 minus u squared. And what is my u again? Just x, I think, right? Plus the other way around. Bring down the arc cosine of x times what's the derivative of 2x? 2. Plus, or actually it's a minus here, isn't it? This is a minus. Now I need the derivative here. I'm going to keep the 2 out as a constant factor. Its square root is a 1/2 power. So power times base to the 1 less power times the derivative of the base, which I think is 0 minus 2x. So I have negative 2x over radical 1 minus x squared plus 2 arc cosine of x. Let me spell it right. Arc cosine of x. And over here, I see that the 2 and the 1/2 might cancel. I see a negative and a negative, which makes it a positive. And I see a 2x on top, and this means a square root on the bottom. So when you add something and its opposite, they add to 0, making your derivative simply 2 times the arc cosine of x. So that was the response or answer I was looking for. Number 15. I asked a couple of things about a 10-foot ladder leaning on a wall, which I tried to draw a diagram of, and the base being pulled away from the wall at 2 feet per second. When the base is 6 feet from the wall, so the bottom here, this length right here changes. Yes, it equals 6 at one instant, but in general, it is changing, just like this side is changing. And how fast is x changing? Well, it's changing at 2 feet per second. And so that would make that dx dt. It's positive because x is increasing. If it was decreasing, the derivative would be negative. Now, I'm asking first how fast the top is moving down the wall. According to the way that I have it labeled, for part A, they want us to find dy dt, I believe. So I'm going to write Pythagorean theorem using my constants. So I have, I believe, x squared legs squared plus legs squared equals hypotenuse squared. I'm able to call that 10 because it doesn't change. It's always 10. Take the derivative, power times the base to 1 less power times the derivative of the base. So that's 2x dx dt plus 2y dy dt, and the derivative of a constant is 0. So we're going to substitute all this in, and I'm going to try to find dy dt. So what do I know? I know that dx dt is 2. So this is 2. It says at the instant x is 6, so x would be 6. You might be able to do Pythagorean theorem or know your Pythagorean triples. 3, 4, 5 doubles into 6, 8, 10. So the y is an 8. So if I solve this for dy dt, I'd have to subtract the 24 over and divide by 16. 8 goes into 24 3 times. 8 goes into 16 twice. And I think the measurements of length would be feet, and the units of time would be seconds. So that would be my answer for part A. B is asking at that exact same instant in time, how fast is this enclosed triangular area changing? Well, what's the area of a triangle? Half base times height. I have my base as x and my height as y. I want to find out how fast the area is changing, so they want us to find dA dt. I will do a derivative of x times y. Product rule, x times the derivative of y plus y times the derivative of x. And I think I, in fact, know all these values to be able to answer the question after I plug them in. So x, I think, was 6, so I put a 6. dy dt we found down here to be negative 3 over 2. Y, I think, was 8. And dx dt is 2. So I just need to simplify this. This would be 18 over 2, which is 9, and I think it's negative, right? And this is what? 8 times 2 is 16. So I think that makes it 7 over 2, or 3.5, for how fast the area is changing at that time. Area is measured in square feet. Time has been in seconds. So this is your answer for part B, how fast the triangular area is changing at that time. I'm trying to find the derivative of 1/2 times x times y. And I'm going to do it as a product rule. So this is u times v. So u is the x, v prime is the derivative of y, which is dy dt, plus v, which is y, times u prime, which would be the derivative of x, or dx dt. So yes, there was a product rule involved. On number 16, a ball is thrown upward at 64 feet per second from the top of a 192-foot tower. It will go up, reach its maximum height, and come down. Now, it doesn't go horizontally, it's just going up and down. On its way up, the velocity is positive. On the way down, the velocity is negative. On a number line, what is between positives and negatives? Zero. So at the very highest point, the velocity is 0. So I'm going to take my projectile motion formula here. 1/2 g is 1/2 the acceleration due to gravity. It's either negative 32 feet per second or negative 9.8 meters per second. Because this is in terms of feet, I use feet. So 1/2 times negative 32 should be a negative 16 t squared. So it's a negative 16 t squared plus v sub o t. V sub o, anything sub o means initial, v means velocity. So the initial velocity was a positive 64 because that's how this velocity was thrown upward, the initial. And the initial height was 192. So I have my position function. X of t equals negative 16t squared plus 64. I could take the derivative of the position. And that's called velocity. The velocity in this, the derivative would be negative 32t because of the negative 16t squared. And this is plus 192, right? So what's the derivative of 64t? 64, and the derivative of 192 is 0. So I have my velocity function. Part A says, how high does the ball reach? Well, I told you at the maximum height, the velocity is 0. So I make my velocity equal 0, and that tells me the time. So it's at the top at time 2 seconds. How can I tell how high it is? By putting 2 into the position. The time at that time into the position function. So if I put a 2 in, I think I get, put a 2. So what is this? 4 times that is negative 64 plus 128 plus 192. So this is 64, I think. Is that right? Plus 192. And I think that makes it 256 feet off the ground at time 2. So that's the maximum height the ball attains. Now that's your answer for part A. Part B asks, find the velocity when it hits the ground. So it wants us to find the velocity. So I'm still going to use my velocity formula, which is this. Okay, so I need to use this velocity formula because it's asking the velocity when it hits the ground. Well, I might also need the position function. So that would be negative 16t squared plus 64t plus 192. That's the height above the ground. When it hits the ground, the height above the ground is 0. So I make this equal 0. I'm going to factor a negative 16 out, or use a quadratic formula, or use my graphing calculator. One of those. 16 times what is 192? Is it 12? Let me check. Okay, so now I'm going to factor this. Negative 16, this will factor into t minus 6 and t plus 2, I believe. So that's the position, and that's when it equals 0, right? So what makes this 0 is either time is 6 seconds or time is negative 2 seconds, but that's before the event occurred. So the time time is 6, that's what you have to put into velocity function, because they want to know the velocity when it hits the ground. So it's 6 seconds is the time it hits the ground, but we want to know what the velocity is when it hits the ground. So I think this becomes negative 192 plus 64. Let me check my arithmetic. So my velocity at time 6 should be negative 128 feet per second. Now, the should make sense that the velocity is negative because the object is falling downward, going downward, which means a negative velocity. If it was going upward, it would have had a positive velocity. But this is going downward, so it should have a negative velocity. I hope these help understanding of this quiz.